Hello and welcome to this AQA Further Math Statistics video. The third in the series looking at discrete random variables 1, this time looking at the mean and variance of a discrete probability distribution. Just a reminder of what you should be familiar with from GCSE. You should be familiar with being given a frequency table. So you can see here we have frequency, f, and the mark indicated x, our random variable. We have 20 marks altogether, and in order to find the mean from this table, you would work out the total number of marks altogether, and that's obtained by doing frequency multiplied by mark. So we had 2 5s, 6 6s, etc. And we obtain the total of all of these, and of course you may well do this on your calculator now. And then we divide the total of all the marks by the total of the frequencies, and then we get the mean mark per student, 7.1. In further maths, we're going to be looking at not the mean of a sample, but the expectation of a random variable. And the mean when we have a frequency distribution, so possibly we're given a table with our random variables and frequencies in, is obtained by using this formula, which is the example I just did. And if we separate it out like this, so we have the random variable multiplied by the frequency of that random variable divided by n. So rather than obtaining the overall total, as we did in our example earlier, and then dividing by n, we can regard it as the sum of each outcome multiplied by the frequency of that outcome divided by n. And then those are all summed to obtain the mean. When we're looking at the expectation for a discrete random variable, this formula is changed because we're not going to have frequencies, we're going to have probabilities for each outcome. And so the expected value, or the mean of a discrete random variable, where we're looking at a probability distribution, not a frequency distribution, would be the sum of each outcome multiplied by the probability that that outcome is achieved. And hopefully you can see that that easily links to this formula, because the number of times a particular outcome occurs out of the total is exactly the same as the probability that that particular value occurs. So if we move on to variance, and bear in mind that just as the mean from a frequency distribution is indicated x bar, because it's just a sample mean, if we have a frequency distribution, we will be finding a sample variance. And the sample variance, you may be used to any of these formulae here. This one is quite awkward, having to work out, if you like, the average of the distances squared of each outcome from the mean. I think this formula is probably the one you're more used to. So summing fx squared and averaging that by dividing by n and subtracting the mean squared, which is exactly what you get when this first formula is simplified. And just as we did before, we can write it like this. And you can see again that you could imagine for the first term here, rather than sigma fx squared over n, we could write that as sigma x squared multiplied by f over n. And that of course links to the probability. So the variance for a discrete random variable when we have a probability distribution, and this actually will be the population variance, so we could use the sigma squared notation here. The variance is obtained by doing the sum of each outcome squared multiplied by the individual probability of that outcome minus the mean squared, or the expected value of x squared. and we use mu here because with a probability distribution this will actually be the population mean. So just to summarize that, for a frequency distribution we just have a sample variance here, the variance from that sample. But if we have a discrete random variable with a probability distribution, then we're going to find the population variance, and the formula that we got to on the previous page was this one. Remember, the mean is the same as the expected value of x, and this first expression here, sigma x squared multiplied by the probability x takes that value, is the same as ex squared. So this final formula here in blue is probably the simplest way of remembering how to obtain the variance, and this formula in blue on the bottom line is probably the simplest way to remember how to obtain a variance when you have a discrete random variable and a probability distribution. So to summarize, the expected value or the population mean for a discrete random variable x where we have a probability distribution is sigma xi pi, and the variance of the population for the random variable x is obtained by finding the expected value of x squared minus the mean or the expected value of x squared. And notice that these two are not equal to each other. One of them is the average of the x squared outcomes, one of them is the average of the outcomes for x, and then that result is squared. So if we just have a look at an example now. So we have our probability distribution here for the discrete random variable x that can take the values 1, 2, 3 and 4, and it's a slightly complicated probability distribution. It's 1 over 30, 2 to the power x, and we're going to find the expected value and the variance for x. So if we just make up a table, it's useful to have a probability distribution table here. So obviously when x is 1, we're going to get 2 to the 1 divided by 30. When x is 2, we'd have 2 squared, which is 4 divided by 30, and so on. So to find the expected value, what we need to do is sum each outcome multiplied by the probability of getting it. So we would simply be doing this, and you can, if you like, put those probabilities into your calculator just as you would put frequencies in and use your calculator to obtain the result here. And so you can see there xi pi all written out. We need to sum those, so 2 plus 8 plus 24 plus 64 over 30, and that gives us 49 over 15 if we cancel it down, and 3.27. And do remember, answers should always be given to 3 significant figures unless you're told something different in the exam, and also a mean is not necessarily an integer. So 3.27 is the expected value for x. To find the variance, remember we need to find the expected value of x squared this time. So we've found the values for x multiplied by the probability of getting that value. Now we need to do x squared. So this would be 1 squared multiplied by 2 over 30, 2 squared multiplied by 4 over 30, etc. And here we have all the outcomes for x squared I pi. And to find the variance, and do remember that there are 2 parts to this, so we're focusing on this part at the moment. Don't forget to subtract ex squared. So if we sum all the values in the table, we will get this expression here. So 2, 16, 72 and 256 over 30. And then do remember that you need to subtract the mean squared, and that was our outcome for e of x that we found when we were doing the first part of this example. And then simplifying that, and it comes to quite an awkward fraction here. So again, to three significant figures, the variance is 0.862. And you might like to use the symbol for that as well, 0.862, and remember the standard deviation would be the square root of that outcome, so the square root of 0.862. And that concludes this third session in the series on discrete random variables 1.